A new topic. Okay, so what I've got here is, can everybody read those numbers? Is it big enough to the back? Can you read those numbers right there? Okay, then come forward. You're gonna be watching these numbers. They're gonna change. Okay. So what I have hiding in the shadows here is an accumulation function called f. Okay. Accumulation function called f, and then n. This right here. This n is the x. Whatever n shows is the current value of x, the input into f, and then I'm going to show you for that current value of x. I'm not going to show you the value of f, but I'm going to show you the value of its rate of change, r. Okay, so right now, x is negative 3.83, denoted by n, and the rate of change is positive 30.5. And we're going to look at this dynamically. We're going to look at this in 4 intervals. So the first interval is from negative 4 to negative 2.5. Okay, so I'm going to just let it go, and you can see what happens here. That's too fast. Okay, let's try that. Okay, so all you have to do is watch the integer values, right? Don't worry about the hundredths place or the tenths place. You don't need that. But what this is showing is x increasing from negative 4 to negative 2.5. Again, that's n. All right, and then you're going to look at the rate of change, what it's doing as x increases over this interval. And it just keeps repeating, right? So this black bar is showing you the current value of x. And then when it gets to negative 2.5, it's going to start over. And you'll see that with the values of x. And so what I want you to do as you look at this, yeah, this is going to be tricky. Okay. So what you're going to do as you watch this is you're going to make deductions about the rate. So what is the rate doing, and therefore what is the accumulation function doing? So what do you see the rate doing in this first interval from negative 4 to negative 2.5? Decreasing, and it's also the rate. You could also say the rate is positive or negative. Okay, so it's decreasing and it's positive. So, for instance, in this first section here, we could say that the rate of change is getting less positive. Would you agree with that? In this first section, it's getting less positive. And so then what could you say about the accumulation function if r is getting less positive from negative 4 to negative 2.5? Is it fair? Okay. What does that mean for the accumulation? Yeah.
It's accumulating at a lesser rate.
Okay, but how? So how is it when you say accumulating? Increasing, right? How do you know that it's increasing? Because r is positive. R is positive, so then we could say that f is increasing.
Decreasing rate?
Yeah, but so let's, we're going to keep them separate, okay? So we're just going to focus on what the rate is doing and what f is doing. And we want to avoid these phrases where we're trying to put it all together. Decreasing at a decreasing rate. Increasing. Do it separately, okay? Because when f is decreasing, it gets a little more tricky. And so by cramming those phrases together all at once, you can confuse yourself. So we're going to focus on one thing at a time. So when you're talking about, you say, what is the rate of change doing? And then what is f doing? Okay, so now we're in the second interval here. So from negative 2.5 to negative 1, and you're going to say what? You could say the function r, or the output r of x gets what? And then f, what's your conclusion about f? So talk with someone around you. And you're doing it by the numbers, okay? Go, give it a shot here. Okay, there you go. So keep it separate. Analyze the rate, make your conclusion about F, and keep those separate, okay?
Now, once it does where it's negative values, so then does it decrease?
Okay, so this one's a little different because in this interval, R actually does two things, right? What does it do first? It gets what? Right, so it still continues to get less positive at first, right? And then what happens after that? Okay, more or less negative? Then it goes more to more negative, right? So it's getting less positive in the first part of this interval, and then starts getting more negative. So what about F? So what about F? Okay, so what about F then? So it's getting, R is getting less positive, and then it changes within this interval to getting more negative. What about F? Decreasing. F is decreasing. Agree with that? In this entire interval, F is decreasing.
No. Increasing.
So does what happens to F change because of what happened? The R changed. At first, F is going to increase because the rate is positive, and then F will decrease. So F is going to change too, right? F is going to change too. Okay, so. So would you agree that in that whole interval, though, rate is decreasing?
So this is going to start.
So this is showing two ways that the rate could decrease. It could be getting less positive and more negative. So the rate is still decreasing to the whole thing. But because the rate changed from positive to negative, first the accumulation is increasing and then the accumulation is decreasing. Okay, so did you catch that? So even though we had two parts to that rate, that was supposed to be pause. Why didn't it pause? Pause. Okay. Because there was two parts to that, even though there was two parts to that rate, getting less positive, more negative, both of those are still, the rate is decreasing that whole time. Agree with that? But when the rate is positive, the accumulation is increasing. When the rate is negative, the accumulation is decreasing. Okay, next segment. Are we good? Okay, next sections from -1 to 0.5. So you're breaking down what's happening the way we've been doing so far. So go, -1 to 0.5.
It's getting louder, not softer. So practice using these phrases. Let's stop. Phrases we want to practice.
R is
That's our R left. Oh, that's true. That's true. Yeah. All the ground was like
Okay, starting now.
It's getting louder, not softer. So practice.
R of X is the rate of change. R of X. S of X is the corresponding accumulation. So like the amount. R of X is the rate of change graph. S of X is the accumulation.
Okay, so let's reveal here. What do you think about R in this interval from -1 to 0.5? What do you think about R in this interval?
It's more negative and then less negative.
He's saying more negative at first and then less negative after that. More negative. Okay? So if it's more negative and then less negative,
More negative.
it's getting more negative. All right, so let's just go with that. Yeah, more negative and then less negative.
More negative and then less negative. That's what you should have seen. It's always negative. So, is the rate decreasing or increasing?
Okay, so when it's getting more negative, is the rate increasing or decreasing?
That would be decreasing. Numbers get
More negative.
Increasing.
More
Then
negative.
start
Decreasing. When the rate's getting less negative.
Then increasing.
Decreasing or increasing?
The rate.
Increasing.
What does it mean for?
When values get more negative, those values, it's going down. But when it starts getting less negative, it's going back up again. Okay?
Decreasing the whole
What
rate.
about F then? What can you say about F in this section? Always decreasing or does it change? Always decreasing because the rate is always negative. Anybody have a question? Are we making sense of this? Okay. Where does this? So next one.
And that's going to be our negative rate of change. So this is always decrease, always decrease.
Okay, here's the last interval. Go. Is it running? Yeah. Last interval.
That's the negative. So when it comes back, it's all increasing.
How does it start? It starts.
Whenever the front half of X is decreased, still negative. Yeah, it goes from it starts off say less. Yeah.
Okay, what about here? What about in this interval? What did you see for the rate of change? What happened to the rate of change in this interval? How about in the back? What did you guys see in the back? What did the rate of change do in this interval? Go ahead.
It's always increasing, but at first it's becoming less negative and then positive.
So he said in this interval it was getting less negative, and then it turned positive and started getting more positive. And then so therefore the whole time it was increasing. Lots of nods. Good. Okay? That's right. And therefore F, what? What about F in that case then? Starts off. Okay, so the rate is getting less negative, but it's negative. So the accumulation will start off decreasing, and then the rate turns positive, so the accumulation will increase. Okay? So now, based on this information, can you make a rough sketch? So interval by interval with this information, can you make a sketch? So this is kind of the reverse of what you've done. You kind of had sketches and you've analyzed. Now we've got this information that we got from the numerical analysis based on the rate. Can you make a sketch of the accumulation function f?
Yes.
Go for it. See what you come up with. So it's -4. I'll write down here. This is -4, -2.5, -1, and 0. 0.5 and 2. Those are the x values that break off those 4 intervals.
It's alright.
How's it coming? Not so much progress here. Not really.
Because, like, so for each interval, it's less positive each. So f(x) increases starting in -4. Just put it to 0. So go based off of like n is 1.
When it's increasing, so yeah, f increases, but r is getting less positive over the rate is getting less positive.
It's still negative.
So what is your rate? Your rate is more positive. So how can f increase at the rate of less positive? Because the rates. So you got that f is increasing, but you're showing that the rate is increasing, right? At some point, it's increasing. So you want that to go up, right? But you need the rate to increase.
Because it's getting less positive. So even though f of x is increasing, it's
The rate is how y changes.
So yeah.
The rate increases.
F of x, but it's still is the rate. See, it is still increasing right here. It's just increasing at a decreasing.
No, this is going to go up. Your graph is going to go up.
With this rate,
Decrease. This is the rate increasing. The rate change is shown by slope, right? So I guess it's lesser slope. See but that starts out increasing, not decreasing.
yeah, I graphed the wrong one.
Okay, so try again. So you good start. That's looking good. Okay, so you make some progress here. Yep, people are getting it.
This is 2.5.
So in the first interval, f is increasing, but the rate is getting less positive, or the rate is decreasing. How is that possible? So it's got to be going up. How can it be going up with a decreasing rate? Draw it with your finger in the air. Yeah, it gets less right. Okay. But it keeps doing that in the beginning of the second, right? So it doesn't. It keeps doing that into the second. The same thing, doing less positive and increasing. And then what happens? Okay, so at some point it changes from increasing to decreasing, and when that happens, the accumulation function for a moment, it has a momentary pause in its value. It doesn't go up or down for a moment. If it's gonna start now going down, then there must be a moment where it reaches what? A highest value and pauses for just that one moment. And now it's going to the accumulation is going to decrease, and the rate is going to continue to decrease, get more negative. Draw it with your finger in the air. Are we good so far? And then that keeps going, right? So into this third interval, we have that same thing keeps going. More negative rate and a decreasing. And a decreasing function and a decreasing rate. And then what happens?
It's less negative.
What's it?
The rate of change.
The rate of change gets less negative as the function continues to decrease. Draw it with your finger. So now it's going to, oops, it's doing so good. Something like that. Okay, and then what happens? That continues into this. Until what? Until then the rate of change now becomes positive and the function begins to increase. So at that transition point, well, we have another pause. There's one moment here for some x value where the y value pauses in its value and y changes from decreasing to increasing. Okay, so let's see how we did. There's the sketch I made last semester. We got better this semester?
Yeah.
All right, so then the actual graph. Oh, jeez. So why doesn't it match up? So the actual graph that was based on these numbers, or these numbers were based on, this red one, why doesn't it match up with ours? Okay, so she said we don't know the actual values of the accumulation. We don't know our starting point. When I drew it last semester, I started here right below 0. But so all we knew was about the rate. We didn't know what value of the actual accumulation we had, and so all we could do is kind of get the shape right. But it could have been moved up or down, right? Because we don't know anything about the actual accumulation values. They could have all been up around 1,000. They could have been all down, the accumulation values could have been all down at negative 100 or something like that. All we had to go on was the rate. Okay, so now I'm showing the graph that we just sketched, and I'm showing as x increases, I'm showing a visual of the rate of change.
Here's the same graph. Now I got some questions for you.
Okay, so my first question is, we're going to kind of analyze this now that we have the visual.
Okay, so I'm going to set it going. So this is the same.
And the first question is, where is the accumulation of f decreasing? So in what intervals is the accumulation of F,
If you're thinking about
the
how
accumulation
the rate of
F,
change
the
is
F
changing,
graph,
you're thinking about
where is it decreasing, and how can you give two reasons to support your answer? Two different reasons to support your answer. Okay, go. How can you tell where
first
F
question
is
is, where is the
decreasing
accumulation
and
decreasing?
justify it in two ways?
Determine that in two
Talk about it.
different
Go.
ways. Go, talk about that.
After the zero, because then it has
So like this is like the rate of
I can see that number. It's too small. Around 2 so 5, about 1
But when the accumulation still is increasing as long as isn't it still
Okay, there you go. So where is F decreasing? Where is F decreasing? You may have to approximate a little
So you
bit.
should have said,
Over what intervals is F decreasing?
Negative 1.7 to 1.2.
Okay, I have negative 1.7 to 1.2. Here comes the magic
1.1 or
magic hand.
1.1. Is that what you said?
You agree with that? Negative 1.7 to 1.2.
One of the ways.
Okay, so just that one interval. So what's one way that you can say, this is how I know that F is decreasing for negative 1.7 to 1.2? Let's go someone in the back. Yeah, tell me.
Rate of change is negative.
Okay, so this red line that I'm showing you, which is representing, its slope represents the rate of change. You're saying in that interval, that slope is negative. It falls from left to right. Okay? What's another way that you know that the F is decreasing from negative 1.7 to 1.2? It's another way that you know that.
You usually look at it, you can see it go down.
Yeah, F is going down. Exactly. The blue graph is going down. As X increases, its value decreases, so the graph heads down. Okay, good. All right, so let's ask the next question here. Okay, now, next question.
Someone in the back. The rate of change is becoming less positive.
If the rate of change is decreasing, so that first question was about F decreasing. Now I want to talk about the rate of change decreasing.
All right.
So my first question is, that could mean one of two things to help us with this. That, right, it means that the rate is becoming less positive or more negative. So, on what interval is the rate of change decreasing? Go, talk about it. Or intervals. What interval or intervals is the rate of change decreasing? Meaning it's becoming less positive or more negative.
So here's the test. If our now let's talk about the rate of change decreasing.
Oh,
Still becoming less positive from like
That could mean one of two things. There's two different ways that we talked about earlier in class. Rate of change be decreasing. Rate of change is becoming what or what? If the rate of change is decreasing.
Yeah.
Rate of change is becoming less positive
So the other
probably
one
before the
negative.
before it starts going down.
decreasing at a slower rate.
No, it's becoming less positive.
question is, I hear a lot of conversations kind of getting off track. Where's the rate of change decreasing? Where's the rate of change decreasing? Take another
So we're
minute.
talking about Rx is decreasing.
Starting at -2,
Maybe.
and then it's also decreasing.
There we go.
Starting at.
So here's the test.
Okay, and to help you that means that the rate is becoming less positive or more negative. Or is the rate of change decreasing?
But again, if the function is decreasing, that means the rate of change is negative. If the function is increasing, the rate of change is positive. Okay?
Before it starts going down, it's still decreasing.
Now, let's talk
Okay, this is harder, right? This is harder.
Decreasing rate, yes, but it was becoming less positive.
All I'm asking is, where's the rate decreasing? And that could happen in two ways. The rate could be becoming less positive, or the rate could be becoming more negative. So, somebody new, what do you
rate of
think?
change is becoming
Yes, sir.
what or what if the rate of change is decreasing?
-4 to 0. So, can you explain your answer?
Go to the back.
So like the tangent line.
Rate of change is becoming
starts going less
less
positive.
positive,
Right there.
or more
Right,
negative.
right where?
Where the x value is, and when it gets to 0, it stops becoming more negative, and then starts to
Next question.
do it.
But you said -4, so what's going on over here? You think that the rate is decreasing over here? Do you think it's decreasing over here? You said -4 to 0, so
So we're talking about Rx is
you
decreasing.
think that the rate is decreasing in the range of -4 to -2?
Maybe. Let's do this.
Yeah, the rate keeps going down.
Okay,
So here's the test.
less positive. From -4 to -2, the rate of change is getting less positive.
If
Does everybody
Rx
see
is
that?
decreasing, what
So
can
the
you say
rate
about
is?
the rate of change of Rx?
Decreasing. And then what about after it gets over the high point?
What about the rate of change of Rx?
The rate is still getting decreasing because it's now getting more negative. So less positive to more negative. So what about his answer? -4 to 0.
So just think of Rx as just a function. Forget about the fact that it's the rate of change of something else.
-4 to 1.2.
-4 to maybe -0.5, if we want to be a little more precise. But yes, he got the idea right. Somewhere around here, what happens to the rate of change? It changes to. Oh, well, that's not going to help.
It's less negative.
Less negative. So, rate's getting less positive. Now the rate's getting more negative.
So just
But
think
somewhere around here, what happens to the rate? It starts getting less negative. So the rate's increasing now.
Why'd you pick negative point?
I'm not hearing enough
Okay,
people
what would
say
you pick?
I don't know,
negative.
it doesn't look like.
So
Well, what's happening? The rate is, see, it's getting, right now it's getting less positive. Okay?
I don't understand.
Do you don't understand? Okay, that's important.
I don't understand from like -4 to like -2 why we're considering that it's decreasing. Are we putting less positive?
Just this down.
The rate of change is becoming what or what if the
Okay,
rate of
so
change is
from -4 to -2, what is the rate of change doing?
Hearing some people say it.
It's getting less positive. The rate is getting less positive,
The
so
rate
it's
of change is
decreasing.
becoming
Still getting less
less
positive.
positive,
Now the rate is getting more and more negative
more negative.
until about here, and now the rate starts getting less negative and more positive.
All right.
So there's some breakpoint here where that rate.
So long as it's outside of like our graphical curve, then I don't even know like, what the word is for that. But you know what I'm saying? Like as long as the triangle stays outside of our curve, then it's considered positive, right? Because inside, I mean,
So
it
we're
looks
talking
like on
about
this side
Rx
it is getting
decreasing.
more positive, but it's not because it's inside the curve of like the graph.
I'm not tracking with you exactly there.
Let's do this.
If you're looking at the red line is showing the rate of change, right?
Right.
So that red line is
Here's the
getting
test.
showing less of a change in y for a change in x here. Less positive change in y. And now it's showing
Rx
more
is
of a,
decreasing.
through here,
What can you
it
say
shows
about the
more
rate
of a
change of
negative change in y for a change in x.
Rx is decreasing. And what about
And
the
until
rate
somewhere in
change of
here
Rx?
where now it's that slope, that rate of change is getting less negative and then more positive. But you have to take your quiz. So we'll continue this discussion Wednesday.
to the left.
Okay, when they get to the back, pass left and right. When they get to the back. Actually, yeah. Mostly right. Mostly right. Pass to the right when they get to the back. Up here to the right.
Wednesday. Because I wasn't supposed to be here Friday.
Okay.
And then she moved to Monday, so
Okay.
thank you.
There's two. It's double-sided. Okay, there's double-sided.